So we have now established from basic vector principles that if we add two vectors together properly, which is to say we put tail to head and then follow through tail to head, in that order we end up with what is called a resultant or net vector, which in this case can be written as our first vector A plus our second vector B equals a third vector C. Now, supposing we wanted to find a vector that is exactly 90 degrees to another vector. Don't ask me why, that comes later. Previous videos have talked about slope. So let us take our first vector, which was A, and if we define a set of axes, which is x and y, we can always resolve our vector using those principles we talked about earlier into a horizontal or x component, so parallel to the x-axis, and a vertical or y component. Rise over run. Looks familiar, right? So if our rise is, say, for example, +1 and our run is +5. So for every 5 units we go across, we go up 1. We can say, of course, that our slope is 1/5. We can also say that because we're going a distance of +5 in the x direction and +1 in the y direction, that our vector can also be written as 5, 1 in square brackets. So if we write our vector simply as 5, 1, is understood that we are now going across +5 in the x direction and then +1 in the y direction, like so. If we take our original vector and we want to find something that's 90 degrees, the easiest way to picture this, folks, is for me to actually take the entire board and rotate it 90 degrees. So watch this. 90 degrees now means that our vector here, if you picture the original one, was going up 1 for every 5 across. Now it's going this way. So our original vector looked like this. It is now going like this. So because we've turned it 90 degrees, we now have our 90-degree angle. But hey, those of you who are thinking ahead have already spotted where this is going. Our new vector, which I'm going to call A prime, as opposed to our original A, which is here. Our new vector A prime, which is our normal, that means at 90 degrees to the original, is now going 1 across and 5 down. Therefore, A prime, or the normal vector, is, let's say that again, 1 across in the x direction and -5. This is, of course, exactly the same as our original vector's numbers switched around. We switched x and y. And now we have to change it from a positive to negative, because before it was going uphill, now it's going downhill. You may recognize this from previous lessons on slope. If I bring it back together here, we can take another trick by going back and adding our vectors together. So, our original vector, A, as you remember, was 5 across and 1 up. Our normal vector, which is at 90 degrees, went 1 across and 5 down. Now supposing we add them together. Supposing we add them to get a resultant vector. We started here, we now end up here. If we put these two together here, we notice that we went 5 across and another 1 across, so that gives us 5 plus 1. Well, we've now gone 5 across plus another 1, that's 6 across here. And we went 1 up, but then we went 5 down. I know it's not exactly the scale. So just repeat that again. In our first original vector A, we went 1 up, but then we dropped 5. That means that we went exactly how much? We went 1 minus 5, which is -4. Notice that all we did was we added the x values together. 5 plus 1 equals 6, and we added the y values together. 1 add -5 is -4, and our resultant vector C is thus 6 minus 4. See how neatly it all fits together? Now you could rig up something like this in real life using, for example, hockey pucks or slingshots to ricochet at certain angles, but I don't recommend it. I do suggest that you leave comedy to the professionals. Otherwise, as they say, somebody's going to get hurt real bad.